Okay, so we're looking at the Unit 3 practice test. There's 10 questions, 4 points a pop on the short answer, and 3 questions that are of the longer variety. So we'll go through each of them, and I apologize for the format. Kind of stuck with the inadequacies of Blackboard, so it is what it is, as they say sometimes. All right, but I'll just kind of talk you through the parts that are sort of cut off. So question number 1, a market research firm is hired by a nationally known cosmetics company to test new formulations of moisturizer. All right, so there's more to it. Using their extensive list of possible subjects, the market researchers first divide the subjects into 5 age groups, and then randomly select names from each group to participate in the study. All right, so what they're saying here is that they had a population to work with. They broke that population up into 5 subgroups. And then randomly selected names from each of those subgroups. All right, so those subgroups, one might call those strata, as in stratified random sample. All right, but it is possible that this is not a stratified random sample. All right, there are, some similarities between cluster sampling and stratified sampling, and that has to do with how, once they're broken up into groups, how the randomization occurs from there. All right, so if there is a small little element of individuals that are taken from each of the subsets or the subgroups, the strata, then put together to form the sample, then that's going to be the stratified random sample case. All right, number 2, creating a sample of students by starting with the second name in the student directory and selecting every 15th name is best described as a systematic sample. All right, so whenever you're looking at the sequence of individuals based off of some predetermined criteria, that's going to be a systematic sample. All right, it looks like a little typo there. That should be a 1.5 instead of an I5. Not on the highway here. All right, so number 3, which of the following are true statements? Select all that apply. Those are dangerous. All right, so the first one, the census aims to obtain information about an entire population by studying a small sample. No. Census does not study a small sample. It studies the entire population. Sample surveys are experiments. I don't even know what that means. I mean, you might use a sample survey while conducting an experiment, but it doesn't make it an experiment. All right, it does get cut off the rest of the way. The next one is a treatment is imposed in an observational study. Definitely not true. And so that would be none of the above. All right, so none of these. Fortunately or unfortunately, depending on where you're sitting, tend to telegraph the no solution problems, because you look at all the other questions, all the other multiple choice questions, and you don't see many that are of the no solution variety. So you definitely take a good hard look at the ones that have that as a choice, because odds are it's worth looking at. All right, number 4, a researcher plans a study to examine the attitudes of residents of California towards a proposal in Congress to declare English to be the official language of the state. He obtains a random sample of 50 residents of one community in California, and all agree to participate. Which of the following statements is true? All right, so this is a poorly designed survey because it's a voluntary response sample. Well, he obtains a random sample of 50 residents. They didn't say anything about them volunteering. They agreed to participate, but everybody's got to agree to participate if they're asked to be part of a study of some kind. So just because you agreed to participate doesn't mean that you volunteered to participate. You know, it's the difference between being asked and asking yourself. All right, so that's not the case. The design of the study may be biased because the sample may not represent the population of interest. Well, the population of interest appears to be the entire state of California. 50 residents of one community? Well, which community is it? Is it a English-speaking community? Or Spanish-speaking community or other? You know, I'm in California. There's a lot of different languages that are prevalent in California, so maybe it's a Chinese-speaking community. Sorry, cough drop. So, what are we working with here? You know, so yeah, that seems to be a true statement. It is a well-designed survey. Well, there's nothing well-designed about it, because when you have 50 residents that are asked to make the decisions or polled to make a decision regarding an entire state, that can't be a good thing. All right, so we'll toss that one. As long as the respondents were randomly selected, there's no bias. Well, not necessarily. It depends on in what random nature they were selected, what sort of random technique was used. And then also you throw on top of that the fact that, again, because it's from one community, what is the nature of that community? Right? So there's inherent bias there. So it's got to be this one. All right. Now, number 5, again, another one that got cut off. So I think the most important parts of it are still in play here, though. But you have, and I think the p-value one is the one that got cut off, so that's important. So I'll just kind of jot that down in there. That's this one. It's compute the p-value. All right. So the following is a list of required steps for a significance test that are out of order. Put them in the correct order. All right. So, well, conclusion should be the last thing. You take a look at the different options. We see that we have a p-value, you have a test, identify the test to be used and justify the conditions for using it. That sounds like numero uno right there. Like, what hypothesis test are we using? That seems to make sense. All right. The null and alternative hypotheses. Well, yeah. All right. State the significance level for which you would decide to reject the null versus correct conclusions, p-values. Well, those seem to all happen later on in the process. And the test statistic, the same deal. So 3 would be the alpha value. Then afterwards, we would compute the test statistic, because the test statistic helps us figure out the p-value. So 4, then 5, and the very last thing would be drawing the conclusion in the context of the problem. Okay. So number 6, teacher claims that on average less than 10 of his students have been watching his lesson videos on his YouTube channel. The null and alternative hypotheses you would use to test this claim would be, well, it better involve a less than symbol, right? Less than 10. So that would be this one. The null hypothesis always involves an equal sign, so no help there. All right, all of the null hypotheses were the same, but if there was one that involved something other than an equal sign, we would toss that. All right, but the one that involves a less than symbol is the one that we want for the alternative. All right, which of the following should she use? Well, I suppose there's more to that question, right? So let me read the whole thing. A researcher is interested in establishing a cause and effect relationship between exercise and percentage of body fat. All right, so cause and effect. Cause and effect is only established through a controlled experiment. So as long as you know that fact, this question becomes a really easy one. All right. Number 8, you're going to conduct an experiment to determine whether a particular brand of cat food promotes significant growth in kittens ages 4 months to 1 year. You collect a random sample of 20 kittens and measure their lengths before and after they are placed before and after. Okay, so keep that in mind. On a 6-week regimen where the only food source was this particular brand of cat food. The design of this study is best described as if they said the words match pairs in there anywhere, we're going to be in good shape, right? And that's because they have the words before and after. All right, before and after. You have a single sample of individuals with multiple measurements being taken, specifically 2 measurements, before the treatment and then after the treatment. All right, oh look, match pairs experiment. Boom, shakalaka. All right, so all these other things may be in play, it's possible, but, and by the way, a voluntary response observational experiment, there's no such thing. All right. A longitudinal design at the tertiary level, I just made that up. All right. Although it is probably possible that could exist. You know, you would have to establish what the different levels are, but that doesn't seem to be applicable here. A double-blind controlled experiment. I mean, well, we would only blind the study if the kittens had some sort of perception that could be measured. I suppose they could, but the keywords before and after trumps all that. All right. So number 9, a standard IQ test. Now, so we have to do some computation here. Standard IQ test produces normally distributed results with a mean of 100 and a standard deviation. Really have no room on the next page for it either. Standard deviation of 15. What proportion of population has an IQ greater than 130? All right, so they're telling us that mu is equal to 100 and sigma is equal to, because it's for a population of 15. All right, so we want to know the probability, probability that an individual selected at random really has a value, an IQ value greater than 130. So we'd say X is greater than 130. So I'd figure out the Z statistic for 130 minus 100 over 15. So it actually gives us a pretty clean result, Z equals 2. So we are in fact looking for the probability that Z is greater than 2. And so we can whip out the old Desmos calculator here and use our normal distribution function under distributions normal dist 0, 1. Cumulative 2 or more means we're going from 2 to infinity. I'm sorry, more than 2 means we're going from 2 to infinity. So we're looking at 0.0. If we're going to 3 significant, the directions here didn't say that, but we do have to be mindful that they could say that. All right, so just be careful. Just follow whatever the rounding instructions are for the problem. Assume 3 significant unless you're told otherwise. So 0.00228 is what it would be. All right, so that would be our final answer there. So for number 10, the amount of money spent by a customer at an outlet store, I don't even know where this stuff's coming from. An outlet store is a random variable with a mean of 100 and a standard deviation of 30. What is the probability that 50 randomly selected shoppers will spend less than $90? All right, so it's implied that that would be on average because it's 50 of them. So we're talking about the probability that X bar would be less than 90. All right, so this is central limit theorem because we have a group of individuals, sample size 50, and we're looking to draw a probability or determine a probability based off of the statistic associated with that group, in this case the mean. So I would use my modified formula, which is x bar for the z-score, x bar minus mu over sigma over the square root of n. So 90 minus 100 over 30 over the square root of 50. All right, so crunch those numbers. So fraction 90 minus 100, 50 over the, 30 over the square root of 50. So we're looking at a z-score of about negative 2.357. All right, now if we want to be as accurate as possible, the last question that we didn't have a decimal value for z, so we didn't have to worry about it. What I would do is I would store this in as z, so I would save it as z equals rather than just the computation. And if I'm looking for, in this case of saying spend less than 90, so z would be less than negative 2.357. What I would do in my normal distribution function is I would go from negative infinity. You just if you don't want to type in infinity, you could just open a new normal distribution and it'll come with the infinities in there. But if you type in infinity, it automatically changes it over to this symbol. And have it go from negative infinity to z, and it would give you to 3 significant 00921. And now you don't have to worry about putting a rounded value in into this calculator here. All right.